ancient Greek method of finding prime numbers in an array or the hundreds chart. It was created by Eratosthenes, one of those Greek mathematicians from way back. We can use this to identify prime numbers up to 100. The following steps will help us find the prime numbers. Start by crossing out the number 1. Do you know why we cross out the number 1? Any takers? Well, it's because a prime number is any number greater than 1 and only divisible by itself and 1. So 1 cannot be a prime number because it is not greater than 1. Okay, now let's put a circle around the number 2. It is a prime number because it is greater than 1 and is only divisible by itself and 1. 2 is also the only even prime number. Next, we'll cross out all multiples of 2. To find the multiples of 2, simply skip count by 2. For example, 2, 4, 6, 8, 10, and so on. Did you notice any patterns for the multiples of 2? You do realize I can't hear you. They all end in 2, 4, 6, 8, or 0. So if a number ends in 2, 4, 6, 8, or 0, then one of its factors is 2. Next, let's put a circle around 3. It's a prime number because it is greater than 1 and is only divisible by itself and 1. Next, we'll want to cross out all the multiples of 3. To find the multiples of 3, you can skip count by 3. For example, 3, 6, 9, 12, 15, and so on. You'll notice 4 is already crossed out. That's because it's already a multiple of the prime number 2. The next unmarked number is 5. I'll just place a circle around the 5 because it is a prime number. Next, let's skip count by 5s. Do you notice any patterns in the multiples of 5? I sure hope someone got that. They all end in 5 or 0. So if a number ends in 5 or 0, you know one of its factors is 5. 6 is not a prime number. Do you know why? Because 6 has more than 2 factors. Its factors are 1, 6, 2, and 3. All the multiples of 6 are already crossed out, because if a number is a multiple of 6, it already had factors of 2 and 3. Looking at the table, our next unmarked number is 7. It is prime because it is greater than 1 and only has 1 and itself as factors. We'll circle it and then proceed to mark its multiples. Most of 7's multiples are already crossed out because those multiples have more than 2 factors. 8 is not a prime number. Do you know why? Because 8 has more than 2 factors. The factors of 8 are 1, 8, 4, and 2. 8's multiples are already crossed out because if a number is a multiple of 8, it also has a factor of 2. 9 is not a prime number because its factors are 1, 9, and 3. It has more than 2 factors. All of the multiples of 9 have also been crossed out because they have other factors besides 9. For example, 18 is already crossed out because it has factors of 1, 2, 3, 6, 9, and 18. 10 is not a prime number because it has factors of 1, 2, 5, and 10. All the multiples of 2 and 5 have already been crossed out. This also means that all of the multiples of 10 have been crossed out. Now that we found all the multiples of 2 through 10, all we have left that are not circled are prime numbers. Why are they prime numbers? Remember, because they only have factors of 1 in themselves. Our prime numbers between 2 and 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So remember, in order to find a number that is not prime, try to see if it is a multiple